The potential of BCI technology is limitless. With advancements in neuroscience and engineering, it is now possible to use brain-computer interfaces, BCIs, to control robotic limbs, diagnose and treat neurological conditions, and even interact with virtual worlds. BCI technology has been used to help paralyzed individuals regain some mobility and to even enable people with disabilities to communicate with the outside world. However, unlocking the full potential of these brain-computer interfaces requires more than just technological advancements. It also requires the development of powerful and intuitive software applications that can interpret and interact with the signals from the brain. This is where logic programming comes in. Logic programming is a type of computer programming in which complex relationships between data elements are expressed as logical statements. This type of programming is often used in artificial intelligence (AI) applications, where the goal is to make computers think more like humans. With this type of programming, it is possible to create sophisticated algorithms that can interpret complex brain signals and respond to them in meaningful ways. Logic programming is already being used in a variety of BCI applications. For example, BCIs are being used to help people with physical disabilities move robotic limbs. By interpreting brain signals and translating them into commands, logic programming can enable a person to control the movements of a robotic limb with surprising accuracy. Similarly, BCIs are being used in medical applications to detect and diagnose neurological conditions. By using logic programming to interpret brain signals, doctors can detect subtle changes in a patient's brain activity that could indicate the presence of a disease or disorder. Logic programming has also been used to create immersive virtual reality (VR) experiences. By interpreting brain signals and translating them into commands, logic programming can enable a person to interact with a virtual world in a much more natural way. For example, instead of using a game controller, a person could use their thoughts to control a virtual character. This type of technology could also be used in educational settings to create more engaging and immersive experiences. Finally, logic programming can be used to create more accurate and reliable BCI systems by interpreting brain signals and translating them into commands. Logic programming can enable a BCI system to respond more quickly and accurately to input from the brain. This can improve the accuracy and reliability of BCI systems, making them more useful in medical, educational, and everyday settings. In conclusion, logic programming is a powerful tool for unlocking the potential of BCI technology. By using logic programming to interpret and interact with brain signals, it is possible to create sophisticated algorithms that can control robotic limbs, diagnose and treat neurological conditions, and even create immersive virtual reality experiences. With the help of logic programming, BCI technology can become even more powerful and precise, unlocking a better future for all.